reference angles. An angle's reference angle is the measurement of the smallest positive acute angle formed by the terminal side and the horizontal axis. Refer to the diagram below. Look at this. The reference angle is this angle here. So if you have a point in quadrant 1, and if I draw a terminal ray, this is the reference angle. If I have a point in quadrant 2 and I draw a terminal ray, then this is the reference angle, this one here. And it's positive, meaning that it must come from the terminal ray to the x-axis. Understood? Because going counterclockwise, we have positive angles. Going clockwise, we have negative angles. If you have an angle, if you have a point in quadrant 3, then the angle from the horizontal axis to the terminal ray is referred to as the reference angle. Theta reference, theta reference, theta reference here as well. Here as well, you can see if you have a point in quadrant 4, draw a terminal ray. This is referred to as the reference angle. It's the angle from the terminal ray to the horizontal axis. That's why I called it theta reference. This is an extremely important topic because when you successfully understand this topic, you will understand equivalent trigonometric values, how two different angles yield the exact same answer. I will explain this when we go to when we discuss functions again. Again, functions coming to the rescue. Understanding things from a graphical standpoint. Reducing angle measurements. We'll understand reducing angle measurements and the relationship of angles. Keep this at the back of your head when we are working with trigonometry. So these are things that I will elaborate on as we walk through the course. Right. But anyways, for now, you can see that for quadrant 1, the reference angle is equal to the angle in the standard position. Because the angle in the standard position is the angle from the positive x-axis to the terminal ray. In quadrant 2, to get the reference angle, it's the 180 degrees minus the angle in the standard position, which will take all of this here away, and we're left with only this portion here. Right, so that's how we get the reference angle in quadrant 2. To get the reference angle in quadrant 3, so it'll be the angle in the standard position minus 180 degrees. We'll take all of this away, and we're left with only the reference angle. And the reference angle in quadrant 4 will be 360 degrees. Subtract the angle in the standard position. We'll take all of this away, and we're left with only this small portion here, which is the reference angle. Again, I will explain the significance of this. So keep these two ideas, bounce with these ideas. Think about the reference angle and the angle in the standard position. Reference angle and angle in the standard position. I just keep and understand the difference between these two. You don't worry about this here. Again, I have not explained functions, so I cannot elaborate on this idea. But this theta 1, theta 2, theta 3 and theta 4 refers to the angles in the standard position. So it's a quadrant 1 angle, quadrant 2 angle, see quadrant 2 angle, a quadrant 3 angle, angle in the standard position, and a quadrant 4 angle. Right, that's what we mean by angle in the standard position. Why are reference angles important? Because to find the angle in the standard position, we must first find the reference angle. And to find the reference angle, given a point in the Cartesian plane, as shown on the previous page, we must use the magnitude of the sides and treat the right angle triangle with no position. This is a rule best by practice. You can use the actual coordinates, but then the rules that we will discuss on the next page will not apply. Listen to what I'm saying. Listen to what I'm saying. See, when we calculated for beta, see what is beta? Beta is a quadrant 3 angle, which is an angle in the standard position for this terminal ray here. Before I could calculate for beta, see how calculated I was. Before I could calculate for beta, what did I calculate for? I calculated alpha. Think about that. Before I could calculate for beta, I calculated for alpha. But when I calculated for alpha, I did not take the position of the sides. I took the length of it, and I even stated it here for the reasons that I've already mentioned. So whenever you are calculating a reference angle, what are reference angles? It is these angles here. These angles here. Whenever you are calculating them, you must take the magnitude of the sides and not the direction. So although this here will be, let's say, minus 3. What's the magnitude? What's the numerical value of it? It is 3. Minus is showing the direction of it. It's going down 3 units. But if you look at it only for the magnitude, it is 3. So it's almost as if I'm taking this triangle and I am redrawing it here. Right? And I'm just thinking of it as a 3 by 4. Let's say this was 4 and this was 3. Minus 3 plus 4. Then I'm drawing a 4 by 3 triangle here. Irrespective of the direction, I just pulled it out and located it. So whenever you working for the reference angle, it is important that you take the magnitude of the sides and not the direction. And again, I said that this is a rule best by practice. This is a rule best by practice. Can you take the actual coordinates? Can you take the direction? Yes, you can. But for uniformity and for logic, we use the length of the sides or the magnitudes of the sides to find the reference angle. Understood? Why do we need to find the reference angle? Because when you're trying to find the angle in the standard position, like the quadrant 1, the quadrant 2, the quadrant 3, or the quadrant 4 angle, then you need to use the reference angle. So what I'm saying is, when we're trying to find this angle beta, according to what we've learned and according to our rules, we say that in order for you to find beta, you need to find alpha. And in order for you to find alpha, you do not use the direction. See, this is -3, that is -4. I did not use the -3 and the -4. I took the 3 and the 4. So I redrew the triangle here and I treated this as a normal triangle, and I just found out what alpha is. Understood? Because once you start putting signs to this, like when you work with in other quadrants and you start using signs, this becomes confusing. This is why I say best by practice. After working with thousands of questions, we understand that there's certain limitations. Can you use other rules? Yes, you can. But what's the best possible way that we can use it? Is, if you're trying to find an angle in the standard position, find the reference angle. But in order to find the reference angle, we need to take the sides of the triangle that we have, but ignore the direction. Ignore the minus sign, ignore the minus sign here. Take only the positives. Take only the positives. So if I had a -3 and -4, I ignored the negative sign, because the negative sign is telling me that I went 4 units to the left. And this negative sign is telling me I went 4 units down from the region. Understood? But I took only the 3 and only the 4. Because to find the reference angle, use the length of the sides and not the position. Take only the positive values. Let me repeat that. To find the reference angle, take only the magnitude of the sides. Take only the length of it. Okay.